We have the 13th class for integration. This is the second video for substitution method. There are three key points you need to understand about substitution method. One, what prompts you for you to use substitution method? Is it just an alternative way you want to solve the problem, or is it that you cannot avoid it? These are key points you need to understand. Yes, I believe that once you can avoid substitution method, it is always easier. Okay. Now, looking at the denominator, it is actually a single term. Yeah. For this term, if you expand it, the power is 2. When the power is 2, you add 1, it will give you 3 terms. So it will not give you what? One term. Yeah, though it appears to be like one term, because when a expression is enclosed in bracket, we regard it to be one term. But remember, this one has a power like this. So it means we cannot avoid substitution method. So that is one case. The next case is, okay, first of all, here is a problem. X minus 1 divided by x plus 1 squared dx. Limit range from 1 to 3. Okay. So the thing is, we want to use substitution method. Okay. What exactly do we use to substitute? Because using substitution method, we need to bring in a new variable. Most times we say u. So we say let u equal to. Let u equal to. But are we going to say let u equal to x minus 1? Are we going to say let u equal to x plus 1? Or let u equal to x plus 1 squared? Well, we cannot say let u equal to x plus 1 squared, because once the power is here, if we differentiate, the power will still become what? It will reduce to 1. And once it's reduced to 1, here is a plus sign, it will not give us this. So it is advisable for us to use what? To use only what is in the bracket. So we say let u equal to x plus 1. Let u equals to x plus 1. So once you've said let a different letter or a new letter equal to something you so desire, you have to make sure that everything instead of x becomes u. If you choose to say let k equal to this, everything has to go from x to k. Okay. So now what do? We say, now once u is equal to this, we say what? The integral from 1 to 3, this is x minus 1 over, what is x plus 1? X plus 1 is what? X plus 1. X plus 1 is u. So this x plus 1, which is x plus 1 here, is u. So this is u squared. Then this is dx. Do not forget what I keep saying. The new variable is u. So u must replace x everywhere. And don't forget that this 1 and 3 you have as limits, they are here purposely because of x. So if you are trying to move every x to become u, you must also change the limits, because the limits are not for you. The limits are there for x. Okay, so we need to eliminate this. We need to eliminate this x. We need to change the limits. See what we do. Okay, but how do we eliminate this x? We say this one comes here, minus 1 equal to x. U minus 1 is equal to what? X. So what do? Now we have from my, okay, all of this is a waste of time. Okay. Now we say let u equals to this. Now we know that once u is equal to this bracket is now u squared, because x plus 1 is u. So x plus 1 is u squared. So our next target is to eliminate the x. The next other target is to eliminate this x. The other target is 1 and 3. to change. Yes, because everything has to become u. Not only the variables, but also what the limit. So what do we do? Let's target this one first. So we say u against x. We say du over dx. U against x, we are differentiating. So if you differentiate x, what do we get? We get 1. If you differentiate 1, what do we get? 0. We forget about it. But this one is also equal to over 1. So therefore, du times 1 du, dx times 1 dx. So we have succeeded in also eliminating this. How? Whenever we see dx, what do we write? Du. We have succeeded in this. If we see x plus 1 is what? Is u. What is our next two target? This x and this limit. Let's go for the x. How do we eliminate x? Let's make here x the subject. So this is u. We say but u, this one comes here, minus 1 equal to x. So let's go again. If you see the x, what do you write? Du. If you see x plus 1, what do you write? U. If you see x, what do you write? U minus 1. See? Easy. Now we say from this u equal to x plus 1, we are now coming to target what? The limit. Don't forget, these limits are purposely for x. But we are now about to move everything from x to u. So the limit again, we must create that provision. Now, what are the limits? From 1 to 3. So we say if x is 1, why x1? Because this function is in x, the range from 1 to 3. Mathematics, we call them the limit, lower limit, upper limit. So if x is 1, what happens? U is equal to x. What is x? 1 plus 1. What is 1 plus 1? Is 2. I hope you know it, eh? 1 plus 1 is 2. Okay. So again, if x is equal to 3, if x is 3, u is equal to x. What is x now? 3 plus 1. Do you know 3 plus 1? I hope you know it. That is 4. So our limit, the 1 gives us 2. The 3 gives us 4. So let us write our new integral. Okay. So what 1 gives us? 1 gives us 2. How about 3? 3 gives us 4. What x? X gives us u minus 1. And there is minus 1. What x plus 1 gives us? X plus 1 gives us u. This square is this. What the x gives us? The x gives us what? Du. Everything has changed from x to u, including the limit. Okay, so now we say the integral from 2 to 4 u, this is minus 2, 1 minus 1 minus that one, u square du. So this is what we are integrating. Yes. So now we say, oh, wow. Okay, we are going to sum a new field as well. No problem. From 2 to 4, we separate them, this over this, u over u squared, this over this, 2 over u squared du. We keep going, the limit from 2 to 4. Yeah, this u. Okay, there is one u. There are 2 sets of u, eh? So it becomes 1 over u minus 2 over u squared du. I want you to pay attention to something here. Something strange is about to happen. Now, I want to say this is 2 u. This one goes up minus 2. That one is okay. But can we do the same here? We cannot do the same. But I want you to see the reason why we cannot see this. We cannot do the same. Now let's see what is happening. U raised to minus 1. The integral from 2 to 4. We do it here, we must not do it here. But why? Let's see. So how do we integrate? I hope we have minus 1, right? To integrate, we add 1 to the power. We divide by the new power. Minus 1 plus 1 is what? Is 0, undefined. That is the reason. So whenever you want to integrate 1 over x, 1 over u, 1 over y, we cannot do it like this. It will take us to a new field. So I hope you are paying attention. Okay. So we cannot do it this way because once you add 1 to the power, it becomes 0 immediately. The numerator being 0 is not our problem. The denominator being 0 is the problem because it will make it undefined. So we cannot do it. So this one remains like this. So how do we integrate this now? How do we integrate 1 over u? The integral of 1 over u. Now let's say we have 1 over x. Let's say we have 2x over x squared. I want you to listen here. I will give you 3 examples. Let's say we have 3x over x raised to the power 3x minus 8. If you differentiate x, what do we get? We get 1. If you differentiate x, what do we get? We get 2x. If you differentiate x to the power 3x minus 1. Oh, sorry. Imagine. Oh, I'm sorry. Okay, let's just limit this 2 so we don't waste time. When you differentiate the denominator, what do we get? 1. That is the numerator. When you differentiate the denominator, what do we get? We get 2x. That is the numerator. So for every fractional function, a function of this rational function, if you believe or you think or you see that if you differentiate the denominator, the result is going to be exactly as the numerator, the result is the ln of that denominator. Not the numerator, but the denominator. So 1 over x, the integral is ln x. I hope it is clear. It is ln x. So immediately we need to use the natural logarithm. So if you differentiate 1 over u, what do we get? Ln u minus. Here we can still go with the traditional way. You add 1 to the power. If you add 1 to the power, it will become what? Minus 2 plus 1, which is minus 1. So minus 2u raised to minus 2 plus 1. So the new power is minus 2 plus 1. What is minus 2 plus 1? It's minus 1. Can we say plus c? No, because there are limits 2 to 4. 2 to 4. So the limit, ln u, natural logarithm, minus the minus is plus 2u. At the top is minus 1. 2 to 4. How about the 1 remaining? You know, denominator of 1 is not useful for us. It's not necessary to be written. So we say ln u plus 2. This one comes down again, u to the power 1. 2 to 4. So now we can substitute. We substitute 4 first. Wherever we see u, what do we write? 4. So we say ln 4 plus 2 over 4 minus. We go again. Ln, well, this time around we use what? 2. Ln 2 minus 2 over 2. Wherever you see u, you write 4 for the first bracket. Always say minus. Wherever you see u, you write 2 for the second bracket. So we say ln 4 plus this is half. This times this is minus ln 2 minus y minus plus this is 1. Oh, sorry, mistake. Wow. Ln 4 plus 2 over 4 minus ln 2. Here is a plus. So if that one is a plus, minus times plus is minus, minus times plus is minus. Okay, so ln 4 minus ln 2. Ln 4 minus ln 2. Half minus 1 is minus half. Okay, there is something again I want you to see here. Yeah, that is what? Log x over y. Log x over y from the laws of logarithm is what? Log x, because of division, minus log y. This is what? One of the laws of logarithm. So ln 4 minus ln 2, we say ln. So this is 4 divided by 2. 4 divided by 2 minus half. So this implies 2 into 4 is 2. So now we have ln 2 minus half. Okay, so this is the final result. And this ln you see, this ln is the same as logarithm of a number to base e. That is what that ln stands for. Yeah, natural logarithm. So thank you for watching. Don't forget to follow, like, share, and comment. See you in my next video.